So the next section we're going to cover is section 3.1. We're skipping ahead a little bit to the next chapter. If we need to loop back around to section 2.5 later on, we can do it when we need it. For now, I want to keep on moving to new material so that we don't have to spend too long talking about strictly proofs, since those I know are challenging. So we're going to skip ahead to section 3.1 and talk about functions, which should be a familiar idea that you've seen in most of your math classes, at least starting in probably algebra or so. It's where you talked about functions. And in your other math courses, this is probably the idea of a function that you had. Let's see, so there's a question in the chat about whether we'll need proofs later on. And the answer is that, yes, we will need to prove things occasionally, or a few things, but it won't be the primary focus going forward. So it is important that you learn how to do them. But it's not going to be the only thing that we do from now on. Like a lot of these problems from these sections, you won't have to do. From this section, you won't have to do any proofs. You'll just have to use functions, really. Okay, so back to what I was saying. In most of your math classes, I think this is the idea of a function that you probably had. And that's as a rule that assigns to each member of a set another member of a different set. Okay, so maybe that's even a little bit more complicated than you had, more complicated of an idea than you had. So you probably thought of something like, oh, I don't know, a linear function. So this would be, let's say 3x plus 5. So it's a rule that tells you what to do with this number. So x is your input and this is your output. That's what I mean by this. And of course, there were other functions that you've seen, like maybe you've seen the sine function or cosine. You've probably seen logarithms. So you have a pretty good understanding, I think, of what functions are and what they do. But in this section, we're going to get a little bit more of a sophisticated idea using set theory of what functions are. But before we get there, I want to go through this fun little example, or at least I'm going to call it fun, about a checksum. Because, well, functions, unlike proofs, are something that you're actually going to use all of the time if you're programming, which I imagine most of you guys plan to do since you're computer science majors. And this example of a checksum is a common sort of thing that a computer or a computer programmer, website developer will have to do in order to take a credit card number and to see if it's actually a real credit card number. So this is a method, a checksum is a method to detect errors in a credit card number. It's not strictly speaking a security measure. It's a method to see if the person entering the number did it correctly, or if maybe they made a little mistake, like changing two numbers, changing the order of two numbers, or maybe just writing down the wrong number. We can check for that with a checksum. And now we're just going to work through how to do this. So here I have a hypothetical credit card number, and this is the one in your textbook. It doesn't correspond to anyone's actual number, or at least I hope it doesn't. It's just some random digits. So you've probably seen credit card numbers before. They're usually about this long. This one has 16 digits. We're going to break off the last digit because this last digit is what's called the check digit. It's what we're going to use to see if the rest of the number was entered correctly. And then there's a process to follow for the rest of the numbers. Let's see, over here I'm going to write what we're doing. We're going to double every other number starting at the right. So right to left. So starting at 5, we're going to double it to 10, and then you leave the next number alone, double 4 to 8, leave the 5 alone, 7 gets doubled to 14, 3 gets left alone, 1 gets doubled to 2, this 2 gets left alone, this 8 will be doubled to 16, this 5 will be left alone, 3 gets doubled to 6, 0 gets left alone, 9 is doubled to 18, then we bring the 6 down, and finally we'll double 4 to get 8. The next step in the process is to add together any 2-digit numbers that we just created. So add the digits of any 2-digit number. So starting at the right again, we doubled 5 to get 10, which created a 2-digit number. So that means we need to add the 2 digits, 1 and 0, to get 1. And the rest of the numbers we'll leave alone. So the 6 and the 8 will just carry down, and then so will this 5. Here's another 2-digit number. 1 plus 4 gives us another 5. And then we have a 3, a 2, another 2, until we come to 16. So we'll add those two numbers, 1 and 6 together to get 7. And then we bring down the 5, the 6, the 0. Here's our last 2-digit number, 18. So 1 plus 8 gives us a 9. Then we copy down 6 and 8. There's a few more steps to the process. It's fairly elaborate. So now that we have single-digit numbers, we're going to add them all together. So that'll be 8 plus 6 plus 9 plus 0 plus 6 plus 5 plus 7 plus 2 plus 2 plus 3, and then a couple 5s, plus 8 plus 6 plus 1. So add all of this together, which you could try to do in your head or with a calculator. In practice, it'll be a computer doing this addition. So this will come out to 73. Okay, and then one last step, or maybe 2 more steps, depending. If the last digit of the sum is 0, then the check digit is 0. So otherwise, we have to subtract the last digit of our sum from 10. In order to find the check digit. Since our sum was 73, our last digit is 3. So following these instructions, we'll have to do 7 minus 3. Excuse me, I said 7, that is our check digit. We do 10 minus 3 to get 7. Which is our check digit in this example. So the idea is after we follow this process, we get down to a single digit number, 7, and we have to go back to the original card number, way back at the beginning, and compare. So on the credit card, the check digit was 7, and after going through the checksum process, we confirmed that indeed the card number was entered correctly because this checksum matched. So the idea with this checksum, as I mentioned, is that it confirms the credit card number is correct. And there are a few kinds of errors that it'll detect. The primary ones are swapped numbers. So if you swap two numbers, and a single incorrect digit. If you enter two different numbers incorrectly, if you just change two numbers, then it's possible that your checksum is still the same. So it won't check for all errors, but it does catch most of them, the most common kinds. So are there any questions over that process? Or the example? Okay, so no one's asking anything. If you wanted to maybe check your own credit card, see if for its checksum, if you happen to have a, let's see, where's some blank space. If you happen to have a Visa, a MasterCard, an American Express, or what's the last one? Diners Club. If you happen to have one of these kinds of credit cards, then it actually does use this exact method of checksum. So you could take it out of your wallet and do the computations and check it for yourself if you wanted. So any website that accepts credit card numbers is going to perform this kind of checksum on the number before it tries to charge the card to see if the number is actually correct. It can't actually confirm that the person entering the number is really the authorized user. That would be a security check. This one just makes sure the card number is right. Okay, let's see. We have 14 minutes.